Hello my dear students. In the previous video we discussed about chapter 12 current electricity. So we'll continue with current electricity chapter 12. In the last video I taught you some physical quantities related to current electricity. Like number 1, current I is called charge, rate of flow of charges, Q by T, unit coulomb, time second, and you can write unit of current is ampere. A means ampere. Measuring instrument ammeter. Another physical quantity related to current electricity is potential. V is equal to rate work done per unit charge. So work done means joule, charge means coulomb. So you can write V as volt, and by using voltmeter we can measure the potential difference across any conductor, and ammeter in series and voltmeter in parallel. Right. So students, in the last video I taught you about the current and potential. Okay. Today we are going to discuss very important thing, that means Ohm's law. Ohm's law. So students, please write down Ohm's law. Students, whenever you see the video, you always take a copy, pen and pencil, and whatever I discuss here, you just note it down in your copies. Okay, so that you can understand. Okay, so please take out a copy and just put heading Ohm's law. It's a very important questions, might come in your exam. It's a very important question. States Ohm's law. Students, listen. Ohm's law related to current and voltage. Before we going to start Ohm's law, first of all I want to draw a circuit diagram regarding Ohm's law. Students, whenever you want to write or draw the circuit diagram, first of all you have to think, where is the source? Suppose this is the source, and this source actually send the current to the circuit. Then you will draw a key, then a variable resistance. Students, this variable resistance is called rheostat, this is called cell, this is called key. Okay, so rheostat, actually we use rheostat to varying the current, okay, by varying the resistance, like a regulator of a fan. So if you adjust the regulator, actually you passing sometimes more current, sometimes less current, so that you can adjust the speed of the fan. Similarly here also, if you adjust the rheostat, means the resistance, then you can adjusting the current, so that you can send different type of current. And current is measured by ammeter, as I told you. So you will write A means ammeter. Ammeter always connected series with the circuit, and it has a polarity. Suppose this is plus, this is minus, so this plus connected with this plus, and there we can write minus. Then our resistance, this resistance is the actually the appliances, means tube, fan, whatever you want to attach, this is called the resistance. And then you can attach the resistance with the rheostat jockey. Okay, there is a slider. This slider name is called jockey. By adjusting the jockey, you can actually adjusting the resistance. One more thing, students, you have to attach a voltmeter to get the potential difference across the resistance. For that, we'll use a voltmeter, and you can see this voltmeter connected across the resistance. Across the resistance means parallel. So R and V attached parallelly, and see ammeter attached with series. So actually by attaching the potential, we will get the potential difference between these two terminals. And students, here also you have to draw the polarity of voltmeter. That means if it is plus, so we will draw here plus and here is the minus. Okay, so this is your simplified circuit for prove the Ohm's law. In lab, actually you will draw this diagram for experiment of Ohm's law. Now students, actually by applying this cell, we send some current I in the circuit, and this current flows through that circuit. Now you think this current will flow through this resistance but not through the voltmeter. Why? Because students, see this current flowing through the resistance, not through the voltmeter. Okay, why students? Because voltmeter, inside voltmeter there is a high resistance, so resistance cannot flow through the high resistance. High resistance means high obstructions. Later on I will discuss about resistance, but think current always passes through the low resistance, means low obstruction. That you also choose the low obstruction place always rather than crowded place. Okay, same way current also passing through the resistance, not through the voltmeter, because voltmeter has higher resistance. Similarly, ammeter has low resistance. For ideal ammeter you have to select tends to 0, resistance tends to 0, so that all current passes through the ammeter. You will get a perfect reading of current. So student, again I am telling you, current measured by the ammeter, there is a needle, so by the needle deflection you can record the current, and here also there is a needle of voltmeter. By the reading of needle, means the deflection of the reading, you can get the potential difference. Up to this no problem. Now student, think how you can discuss the statement of Ohm's law. So in your questions there will be asked, write the states the Ohm's law. Very important questions. Every year is a very important question for every year student. State the Ohm's law. So whenever students you write the statements, you must also provide the expressions. Okay, so first of all I will discuss statement of Ohm's law. So student, please you write potential difference. Yes, potential difference is directly proportional to the current flowing through the conductor. Students, please say with me, potential difference is directly proportional to the current passing through the conductor, provided by temperature and other physical conditions remain unchanged. You just pause the video and write. Again I am telling you, potential difference is directly proportional to the current passing through the conductor, provided by temperature and other physical conditions remain unaltered or unchanged. So in expression wise, you can also write in expression wise, that means potential difference means V. Okay, you know this is called the potential difference. So sometimes you can write VA minus VB. If this point is A, so the potential is VA. This point is B, so the potential is VB. So change of potential VA minus VB, exactly you can write V. So VA minus VB means change of potential, which is directly proportional to the current passing through the conductor. It means if you increase the potential, see there is a cell, means there is a potential V. Okay, so this potential, by providing the potential means EMF, actually later on I will discuss about EMF. So students, cell actually giving the potential, and this potential, due to this potential, okay, due to this EMF, actually cell actually giving EMF. Okay, so EMF and potential both are same unit. There is slight difference, I will discuss. Okay, so EMF, if the cell provided EMF, then what happened? This EMF means the current flowing through this conductor, and if you increase the potential difference, okay, it will also increase the current. So Ohm states that V proportional to I. So say with me 5 times. V proportional to I. V proportional to I. How many times? V proportional to I. 3. How many times? 5 times. V proportional to I. V proportional to I. So then if you don't want to write the statement, you can write V proportional to I provided by what? Temperature and other physical conditions remain unaltered or unchanged. If the temperature and other physical conditions remain unchanged, then only we can write V proportional to I. Okay. So if you want to do some numericals with this formula, you need to write equal to. So for that we use a constant term, that means V is equal to, constant is called R and then I. This R is called, student, resistance. So you can write this R is called resistance. Okay. So this R is called resistance. Okay. So V is equal to Ri. Up to this you have to write. So the question, write the question, state the Ohm's law. Then we'll write potential difference is directly proportional to current. First, potential difference is directly proportional to current. Potential difference is directly proportional to current. So V proportional to I, V equal to Ri, provided by temperature and other physical conditions remain unaltered. So student, if temperature and other physical conditions like pressure and other things, if unaltered, then only we can write V proportional to I. Otherwise, it may be some different value. Okay. So students, this is the Ohm's law. Now I will draw the graph of Ohm's law. So suppose in y-axis we will draw potential V, and in x-axis we will draw current. Okay. So this is current and this is V, potential difference. Sometimes you can write PD, potential difference, V. Okay. Now students, the graph will be looks like this, straight line. Okay. If you plot current versus potential, suppose you will get in this point. Okay. So that means you will get this type of graph. Students, if suppose you are performing this experiment, then you can draw the graph from the experiment. But student, if you want to draw the graph without experiment, just from the expression, just from the formula, then also you can write the graph. Because student, direct proportion graph, like if y proportional to x means direct proportion. Here what happened? V proportional to I. So V means y and I means x. So direct proportion graph, students, always gives us a straight line and it passing through the origin. So you can write V proportional to I, and you know student, V proportional to I means direct proportion graph always will get a straight line. So that's why we are getting the straight line. Okay. Up to this no problem. So till now I have discussed about what is called Ohm's law. This circuit diagram. Ohm's law states that if you increase the EMF, means the potential, then what happens? The current also increases, and current increases means if V increases, current increases. If you adjust the rheostat, then you can adjusting the current and you will get the potential difference across the R. So this V actually I have written here. Okay. So if you adjusting the current, listen very carefully. Again I am telling you. If you see here, cell is fixed, so constant. So you cannot alter this EMF. Okay. Okay. Understood? EMF is constant. You cannot alter. Suppose this is 1.5 volt. Pencil like battery, you know, used in the clock. Okay. So this is a 1.5 volt EMF which is constant. So you cannot alter it. You cannot alter it. Now this V, actually this EMF sending current, and now you can adjust current with the help of rheostat. This is a regulator type. So you can adjusting the slide, sometimes here, so resistance decreases, sometimes here, so resistance increases. So by adjusting the rheostat, you actually the varying the current, and by varying the current here potential also varying. Means if I increases, V also increases. If I increases, then V also increases. Yes, if I increases, then V all increases. If I decreases, then V decreases. It means you can write V proportional to I. If this is increases, this also increases. If this decreases, then this also decreases. So that's why we are getting this type of graph, which is a straight line passing through the origin. Okay. So up to this I think no problem. If you draw V versus I, you will get a straight line graph. That means V proportional to I. Okay. So by experimentally you can draw the graph. From this you can write V proportional to I. From experimentally you can draw the graph, and from this graph you can conclude that V proportional to I. Okay. So this is your Ohm's law. Now student, one more thing. This question also important regarding this. Okay. This question is, say, if you want to find out R, this R. Student, from this graph, if you draw the slope. So this is called slope. Slope means theta. Okay. So this slope, VI graph slope, represents which physical quantity? Write the question. State Ohm's law. Then in VI graph, draw the VI graph. Okay. This is also another question. Draw the VI graph. And the next question is the slope of VI graph. Students, the slope of VI graph, slope of V versus I graph represent resistance. Okay. So if you draw the slope, actually this length is V, okay, and this length is parallel to current, so I. This length is V and that length is I. So slope means, students, do you know how to find the slope? Slope means, students, so I'm just removing it. Okay. So slope means what? Slope means perpendicular by base. See, right? Slope means tan theta. Tan theta means perpendicular by base. So you can write perpendicular means V and base means I. So V by I. And from this formula, you can write R is equal to V by I. R equal to V by I. Okay, I comes to the denominator, so R equal to V by I. So slope means tan theta equal to perpendicular by base equal to V by I, and that means it represents R. R means resistance. Okay, so slope of VI graph represents resistance. Now, what is the unit of resistance? Students, V means volt, okay, I means ampere, and volt per ampere is called resistance. The unit is ohm, like this. You can write ohm as well as you can draw this. This is called capital omega, okay? This is called omega. So this omega, actually the short form of ohm, this is the SI unit of resistance. There is no such CGS unit. If you want to draw CGS, if you want to write CGS unit, then you can write stat resistance like that, stat ohm like that. So we don't use like this thing, okay? We use SI unit always for this purpose, and the SI unit is resistance. Up to this, no problem, students. Now, students, so if this is resistance, then you tell me now what is called resistance, student? What is called resistance? Resistance means which resist to the flow of current, okay? Which resist the flow of current. So please write, resistance means the obstructions offered to the flow of current by the conductor. Is it easy? Okay. What is called resistance? The obstructions offered. The obstruction offered to the flow of current by the conductor. Okay. the obstructions offered by the obstruction offered due to flow of current by the conductor is called resistance. So this is the definition of resistance, and you will write the SI unit of resistance is ohm. Ohm, and this is called ohm. Okay. So what is called resistance? The obstruction offered to the flow of current by the conductor. Obstruction offered to the current by the conductor is called resistance. Get it? So this is called resistance. Okay. Resistance means which resists the current. Here resistance offered by the appliances. In your household circuit, there is a car, fan, light. They actually offering the resistance to the flow of current. Okay, so that's why this appliances is called resistance. Okay, and the unit is ohm. Now, student, think if the graph is reversed, means if you draw I in the y-axis and x in x, you will draw V. Literally, students, this graph actually legal or valid graph. Okay, because actually V is the independent variable. Sorry, V is the dependent variable, and dependent variable always will write in the x-axis. Okay, so students, here actually you varying the potential. You actually having the potential, and this potential gives you the current. So that's why this graph is more valid than this graph. Okay, so in this graph, so please see very carefully. This is VI graph and this is IV graph. This is I versus V graph. Okay, and that graph also gives you straight line because V proportional to I or I proportional to V both are correct. V proportional to I or I proportional to V both are correct. So if I increases, V also increases. So the graph also valid for this case also. But the difference is that if you draw the slope which gives the perpendicular by base, see, base means V, say yes, in the base means x-axis, so it gives you V, and perpendicular, so base means V and perpendicular gives you what? Current. Okay, this is the perpendicular and it is parallel to which axis? Y-axis. So y-axis means current. So this slope represent actually the reciprocal of resistance, means the opposite word of resistance. Guess it? The name opposite word of resistance means conductance. Yes, right. Conductance. So this graph is represent, the slope of the graph represent I by V, means 1 by R, reciprocal of resistance is called conductance, and conductance, so you can write this is called the conductance. Okay, so remember these things, this is called conductance. Okay, up to this no problem. So student, please pause the video and write everything. Okay, just pause the video and write everything. Next student, listen. Everything written? Next student, see. In the next video, I will discuss about how resistance depends on which factors. Okay? Resistance depends on which factors. What is called resistivity? How you can define resistivity? This thing I will discuss in the next video. Lastly, I want to say that if the graph, VI graph, okay, if the VI graph is not a straight line but it's a curve, then this is called if the graph may be like this, you can draw like this. Student, this graph actually for forward bias of diode, and this graph actually represented by the transistor. Okay, so in class 12, if you are having science, then if you go for science, then you can you know there is a modern physics, and you can learn these things in the class 12. Now listen, for diode and transistor, these are non-linear. The graph is non-linear, not the linear graph. You are getting the non-linear graph. So this is called non-ohmic. Non then ohmic. Okay? Non-ohmic conductor. So please write down one more important question for your exam. Give 2 examples of non-ohmic conductor. Give 2 examples of non-ohmic conductor. Then you can say diode, transistor, because the graph is not linear or non-linear graph. Non-linear. Linear means straight line. Non-linear means curve. Okay. Thank you, students. In the next video, we will discuss the resistance. Okay. The resistance depends on which factors and about resistivity. Okay. Thank you, students.